Welcome to this new video in which we will take a look about this Furuta pendulum and we will put it to action and we will see how does it work, and I will point out the fact that it cost 5,000 euros, so we are pretty lucky. So let's start with the setup. Essentially we have to start by plugging in the cables. So this is the cable, we have to connect it with the transformer. Okay. After that, we have to connect it with the computer. Here we go. So what we should do is to connect not to the host, but to the virtual machine. Okay. Okay, so as interface for the pendulum, you have to do the setup in this way. So you will follow to this GitHub repository how to set up. Essentially you have to use OPENAI gem wrapper for commanding the server motors. Here are the prerequisites. I have done all these commands, and after that you can test it. You can also check it if it works. Oh, so there is the green light. Here the green light, this means that it's connected and working. Essentially now the plan for testing, it has only to swing a little bit, so it is nothing really awesome, but I will show you other interesting plans. So let's remove it. It should stop, it's red. Okay, one thing that you should pay attention is that you have to create the virtual environment. So you have to install Conda, and I already did. We can check the version. And yeah. Okay. Now is maybe my amp. Okay. Why? The reason we are doing that, it's because it's written here that without safely closing the environment, that things may happen. So the environment is essentially an isolated place in your operating system in which you can do whatever you want, and if something goes wrong, it doesn't affect the whole virtual machine but only the environment. So I highly suggest to do that. So we have already like a script open, but there is also an example in which the environment is closed automatically. So we will just copy that and create another script with gedit youtube.python, and we'll open the editor. You just paste it. So we have as plan just that. This is the plan available from gem, OPENAI gem. So for making it more clear, I will open the files. I will go to thesis, Quanser, OPENAI, gem, and environment. Okay, so we have these environments, and for example, this swing up is just the behavior that we have seen before. It's just the pendulum swinging. Okay, now I would like to see something else, so maybe we can use cube balance, and we can just from gmbrt.ends, because we are in amps folder, import not this but cube balance amp, and here we will just copy it and paste it. So we will create the object, and And what it does, so if you are guys a little bit if you a little bit know how the reinforcement works, it's just we take an episode, we reset the environment, so you can think about the pendulum that doesn't know anything about the previous knowledge, and then we'll do a bunch of steps, in this case 250, and he will take actions. So he will have some rewards, a state, and thanks to this reward, in each step he will improve the environment. So I have taken a look about the code. It's just kinematics equations and something like that, in which at the end you will command, as we have seen, two variables, which are the rotation in this direction and the rotation through the motor. So we have just two parameters. And then when we finish the step, he will go to another episode and will reset again the environment. So the fact is that you want to generalize in order to the fact that the model you are creating, it is not affected by what happens before, so it is always new. Okay, anyway, we can just close it. We can come back to the terminal. We can give the right permissions. Okay, and then we can do Python 3, YouTube. Let's see if it works. Okay, essentially it works. The behavior seems like before. Maybe the fact is that if I move it is always in balance, you know? I mean, I can change it, but oh, it is crazy a little bit. So we have seen a little bit how the pendulum works, but as you have seen in the last video, I am not really interested about reinforcement learning. I am interested on creating a data set in order to create a model that from the camera will try to guess the velocity of the pendulum. This is called optical flow, and I have made some algorithms. Maybe I will show you in the later videos. Well, Lucas can add farther back, but it is interesting to bind because now we have the state of this pendulum moving, and if I can write the state in a PDL file, and I can have also the timestamps, and I have also the timestamps of the event-based camera, and I have also the XY position of the pixel. I can create a data set which from the camera events can guess the velocity of the pendulum just by looking it. Some possible application of this could be in robotics, or maybe in cooperative robotics, particularly when in industrial activities where there are two independent robots which doesn't know the state of the other one. So maybe just from seeing the other robot can in some sort guess his state by his motion, by his velocity of the and the factor, and so on. For example, he can understand if it is in a safety issues, which action he is doing. So today I want just for a matter of progress in my thesis, let's try to write the data set. Right now is to go in another script that I prepared a couple of days ago, script.py, and we will access to this script. Essentially it is the same copy paste that we did it before, but now I only opened a file, and I have and after like I print the episode. This it was for debugging. Then we get the state of the environment, and this function will returns a string, an array, of the rotation velocities in the 2 degrees of freedom and also some angles. So maybe I can write this state on a PDF. And one issue that I got is in this row, because after I reset the environment, I will just I am not able to get the state again. I don't know. It's like if it is like going in a other part of the code under the hood, and it is not returning here. So maybe if I print like also here, print chow. Let's remove also here and also here. So if I try to, so what is the behavior? The behavior in the first iteration is that I print a 0 because the episode is a 0 at the beginning. Then I will get the state, and then I will write it, and then I will print chow. This is the behavior that I'm. So if like I do python.script, so I'm getting the 0 here, but I don't see the printed chow. So for this reason, what I did, it's pretty like wrong. But maybe I will talk with the professors. Just what I want is to comment it. So here I will write the state. Here also I will write the state. Why I cannot? Okay. And then I close and synchronize everything. That's perfectly fine. I save it. Okay. Now look at the behavior. Oh god, I always make it wrong. So if we start the scripts, name chow is not defined, yes, because should it be like a string, but you can remove it because you will get that it will work. You will know how. Let's try it. Yeah, as you can see now, it is shown all the episodes. It goes pretty fast, and then we'll return to another episode. And if we like block, we can go to the file that I have created, which is in this folder, no, this, maybe here, and it's not here. It's here somewhere, pendulum states. As you can see here, there are the data sets. So we have like X rotation, Y rotation, angles, oops, and also the timestamp. The timestamps appear to be like in 3, 6, it's like nanoseconds. I should fix that. Anyway, we are getting the state of the pendulum like there is it here. What is that? This is another one. Okay, anyway. After we have it and we test it, what we can do is reset it because we want to synchronize it with the event-based camera. Okay. And maybe in the next video I will show you, after we get this dataset, how we will get the dataset of the event-based camera, and then we will bind them together. Next, I will try to build a PyTorch model and I train it with this dataset, and then maybe we have completed. Let's see. See you in the next video.